I'm Tori Gable, and I did experiment 9, which was the determination of water hardness and complex symmetric titration. The purpose of this experiment was to determine the water hardness of a sample and using a complexometric titration. We'll go over what a titration is and how it was used in this experiment, the results of the lab, the calculations, and also the discussion and the conclusion. Some background is, what is water hardness? Water hardness is the measure of total calcium, magnesium, and even iron cations that are found in water, resulting in the dissolving of limestone bedrock. Why would you care about this? Some water companies would care because they would want to see if their water is soft or hard by all the sediments and everything, and calcium, magnesium, and everything that is in their water. A complex symmetric titration is a method of analysis used to determine the endpoint of a reaction and the exact amount of the reaction in a flask. We used EDTA to put in, and this would initiate a color change to show an endpoint. And the experimental, we used a 500 milliliter bottle, and we went to the freezing cold Mount Union Lake, and we filled it up, and we filled it up 3 times and poured it out, and then the last time we kept it in there, and then a funnel was used and put into a flask so any leftover sediment wouldn't go into the flask and ruin our sample. Then 100 milliliters of the water was put into each of 4 different 250 milliliter flasks. And then HCl was also added to each flask. 3 to 4 drops of methyl indicator was added to each of the flasks, and 0.5 NaOH was added dropwise until there was color change from, as you can see, a pink to a light yellow. 2 milliliters of a pH 10 buffered was added to the flask, and then 0.3 of sodium cyanate and 0.3 of Irochrome black tea indicator were also added to the flask and mixed around. A burette was then filled with EDTA, and the concentration was recorded along with the initial reading of the burette. 4 trials were done, a scratch sample, and 3 other trials. The drops of EDTA were then released from their burette until there was a color change to purple. Once it hit purple, it was then swirled around because it then resulted in a blue color. The final reading of the burette was then taken and recorded. Each step was repeated for all the following flasks, so one was done at one time. Some of the results, this happened on November 11th, 2013 at 7:40 a.m. And this shows that the scratch sample, for example, the final reading was 9.5 milliliters, the initial reading was at 0, and the volume EDTA added was 9.5 milliliters. Some calculations. The first one shows a balance equation showing calcium carbonate dissolved in water. And then the second one shows the balance equation showing how calcium complexes with EDTA. Calculating water hardness, you have to find the moles of EDTA, and the molarity of EDTA equals the moles of EDTA divided by liters. Well, then you use your scratch sample, for example, and I took the molarity times the milliliters and got the moles of EDTA. Calculating the moles of calcium, you take the moles of EDTA times the moles of calcium divided by the moles of EDTA. And then calculating the moles of calcium carbonate, you take the moles of calcium times the moles of calcium carbonate divided by 1 mole of calcium. And then you have to calculate the grams. So there's my scratch sample, and then you convert the grams of calcium carbonate to the milligrams. Finally, once you do that, you have to solve for calcium carbonate per liter. So then you have to solve for X, is pretty much solved for my scratch sample there. And then this table shows each of the milligrams calcium carbonate per liter for each of my samples. The calculation of the average, you just add up all of your milligrams of calcium carbonate and then divide by 3 since there were 3 trials. When calculating the standard deviation, you take the milligrams calculated minus the average, and then you add it to the calcium carbonate calculated minus the average, and then you add it again to the calcium carbonate calculated minus the average, and there's my scratch sample, and the standard deviation was 7.28. And then data interpretation, it asks, using your data, classify the water you tested based on the following table. This gives you the table of how many milligrams per liter you have of calcium carbonate, and this will determine if you have soft to very hard water. In my case, the average was 96.67 milligrams of calcium carbonate per liter, so mine would fall under the category of 50 to 100, being moderately soft. And there's my